Mr. Ansberg here with the first video of lesson 1.1, which is analyzing categorical data. In this part, we're going to look at the first two learning objectives, which are to construct and interpret bar graphs and pie charts and recognize good and bad graphs. So let's go ahead and get started. Before we begin though, we do want to look at the W questions. Who, what, why, when, where, whom, how. These are the important questions to ask before you start analyzing data. Who are the individuals or the observational units the data describes? How many individuals appear in the data? How many variables are there? What are the exact definitions of these variables? In what units is each recorded? Is there any reason to mistrust the values of each of these variables? The why. What is the reason the data were gathered? Do we hope to answer some specific questions? Do we want to draw conclusions about individuals other than the ones we have data for? And these are the questions when we are looking at data we want to ask before we get started on analysis. So before we begin we looked at lesson 1.0, which was categorical versus quantitative. And so we're going to quickly review that before we go into 1.1. And we're going to use the school cafeteria as our individual. And we're going to look at what are some types of categorical and quantitative variables that we have in there. And so if we just take a moment and kind of think about going to the cafeteria, you're walking in lines, you're sitting at tables, you're having your food, is what are the variables that you can see or experience or observe in the cafeteria for them. And so you could pause the video right now and you could take a look and see on your own what variables and kind of make your own list. So pause the video for a minute and you can make your own list of categorical and quantitative and compare it to the list I will show in a few seconds. So the ones I came up with for categorical were side of the cafeteria, the left side or the right side, the old middle school side or the high school side. The type of table, we have booths, there's round tables, there's rectangular tables. What type of table are you sitting at? Students who packed versus students who purchased on it. And then which lunch line did you select? Now, quantitative variables, we have, the number of people at a table, the cost of lunch, the calories per lunch, wait time in a lunch line on it. So these are the ones that I came up with. And we have to keep in mind that when we're dealing with categorical variables, we're looking at it organizes individuals of the data into a set of groups of categories. But quantitative describes individuals using numbers. And one little hint we learned before is when you're dealing with quantitative, it makes sense to take the average of that number for it. So we move on. And we're looking at categorical variables. They place individuals into one of several groups or categories. The values of categorical variable are labels for different categories. The distribution of categorical variable lists the count or percent of individuals who fall into each category. So we can kind of see here types of music. On the left side, we have format as our variable. Our values are the types of music. The count of stations are given right over here. This is a frequency table. Now, a relative frequency table takes those and converts them into percents. So if you were to take the 1,556 and divide by the 13,838, you would get 11.2%, and so on with the 1,196, and you divide by the 13,838, you would get the 8.6. And so we can see here is an idea of how categorical variables can be placed into a table. We have a frequency, which looks at the counts. We also have a relative frequency. A relative frequency looks at the percents on it. Now, when you display in categorical data, we looked at it as a table. Now we can look at it as different graphs. So frequency tables can be difficult to read when you're looking at comparison. When I look at these numbers, I can just see numbers or I can just see percents, and I can't compare them too much. I can see, oh, this number's higher, this number's lower. But what does that mean? So if I look at them visually, it's easier to analyze sometimes the data or the distribution that you're being given. And with categorical, it's pretty easy to look at it with the bar graph or a pie chart. And so on the left side, you see the bar graph, and on the right side, you can see the pie chart. Now let's pay attention to some of the things that are in there for the bar graph and the pie chart. The bar graph itself, it has the axes horizontal and vertical labeled. You can see each category underneath each bar. And notice the y-axis, it starts at 0. It goes up by the same increments each time on it. It is the number of count of stations there. So we have labels. We have a title, we have the x-axis labeled, we have the horizontal axis labeled. Those are crucial when you're looking at graphs, and those are where points are taken off on the AP exam. And it's the same with the pie chart. The pie chart, in this case, there's a lot of categories, so they made a key off to the side, and they were able to color code. Sometimes you can write them in or draw an arrow, but notice each slice is labeled in the percents for them. So you can tell it. And the slices, they're going to add up to approximately 100%. Sometimes it's going to be 99.99% if you're looking at rounding some of the numbers, but it's going to add up to 100%. And that's really important to know when you're looking at pie charts on it. The categorical data, the percents, the relative frequency should add up to be a whole, a 100, just like a pizza. So when we're looking at this, we see all this information. We see tables on it. It can be looked at a lot better with our graphs. We can analyze them. The pie chart has a title. The pie chart is labeled. I mean, these are important things to keep in mind. And so when we look at features and characteristics of bar graphs and pie charts, here's our list. They both need titles. Really important to title. And it's not just bar charts. And it's not just our bar graphs, not just pie charts. It's everything that you're going to look at with graphing. When you always want to title your graph, make sure the person, the grader, knows what you are doing. Label your axes for a bar graph. That's the horizontal and the vertical, which we talked about before, is units are extremely important. When you're looking at a bar graph, the bars do not connect, and the bars need to be the same width. You shouldn't make one wider than the other. That's misleading, and we're going to get into that. And sometimes you can use multiple bars to compare multiple groups. You can do multiple bar graphs in a single one. Pie charts. You again title it. You label the slices and make sure you give the percents in each slice as well. And one other important characteristic, and we didn't see it in this pie chart right here, is write down the total number involved. Now the reason why that's important is because if I say we collected data from 10,000 people and 30% said this, is an easy mathematical calculation to find out the number of people in each slice. So make sure you give the total number of people involved when you're looking at a pie chart as well. So graphs, the last part of 1.1a, good and bad. Bar graphs compare several quantities by comparing the heights of bars to represent those quantities. Our eyes react really quickly to area of those bars. We want to make sure the bars are equally wide. Again, look at that. That's one of these things on this slide, is make sure the bars are the same width. Otherwise, the area is going to be misleading to people's eyes. Avoid the temptation to replace bars with pictures for greater appeal. It can be misleading. You can look at this graph on the lower right-hand side of the screen. And notice that's what they did, is they replaced, they didn't keep the same width. They used an area for the 95, the 81, the 56 for DirecTV, Dish Network, and cable, respectively. Is my eyes are drawn to that 95 being, wow, that is over twice the width of the Dish Network. That area is so much bigger. So that must mean that DirecTV is so much better than the other ones on it. And so it can be very misleading because the bars are not the same. We're using images, we're using pictures on it. Now, this is just one comparison of misleading graphs. And you may think, well, that's nothing. Maybe that hasn't happened before. That's old. People don't do that anymore. I'm going to pause the video for a minute and I'm going to pull up a PDF of some current misleading graphs that have occurred on it. And so right now I have up on my screen just a PDF of some misleading graphs. Now this one's not as current. This one's from 2012. But it is important. There's important characteristics on it. There's things I want you to notice. If we look at this graph and we see it says over 100 million now receiving federal welfare, there's the title. You can look at the bar graph and I'm looking at it and I go, wow, in 2011, the second quarter of that, I mean, that is, man, maybe 2 times or 3 times as high as back in 2009, the first quarter of 2009. And so visually, if I'm just looking at it as a visual, I'm seeing that in 2011, it's 3 times as high as it was in 2009. That's crazy. But I should look at the y-axis scale. I mean, the y-axis scale starts at 94 million and goes up to 108 million. The scale on this y-axis is extremely misleading. It's causing me to draw a conclusion that should not be drawn. It's not 3 times as much as it was back in 2009. It's way less than 3 times. But I didn't start the y scale at 0, and so therefore it's allowing me to mislead people with this graph. Here's a pie chart. Back from 2012 again, you're looking at people who are backing up certain GOP candidates. Now, what's wrong with this one is we look at this pie chart. Well, you got the slices, 60%, 70%, 63%. That looks about pretty wrong. I mean, that's not 70% of the pie chart. That's not 63% of the pie chart. That's not 60% of the pie chart. So even the percents aren't the correct size in this pie chart. And they don't add up to 100%. You have a 70, 60, 130, and 63, 193%. So 193% is what that pie chart adds up to. It doesn't make sense. Here's a sign that someone created. 1/3 of our operating budget goes towards financial aid. There's a pie chart. 20 million is the yellow, 60 million is the red. That is 1/3. But the yellow is a quarter of the pie chart. Again, something that is misleading. Here we have biggest COVID-19 worries, and it's kind of the same idea. Here's a pie chart. So we're going to look at it, 62%. You have 48%, you have 68%. Again, the percents don't make sense. 68% is less than half that pie chart visually. So the percents don't match visually on what's going on, and they add up to be over 100%, just like before. Here's one that I found this summer as well. This one is from Georgia. And it was a chart that they used for analyzing should they reopen their economy or not. And this is a very big one that a lot of stats teachers talked about this summer. Is you look at this and you think that things are, well, it's decreasing. You can see the number of cases decreasing in these counties. Not bad. But there's a lot of misleading things on this. Is first, look at the axes. April 28th. April 27th, April 29th, May 1st, April 30th, May 4th, May 6th, May 5th, May 2nd. The axis isn't in order. They shifted the days around on the x-axis. And even look at the bars. They're color coded. Look, it's got a nice label, a nice key for us to help us see, but they changed the order of the bars in each day as well. And look how they did that. They made it so the bars are decreasing over time for it. So there's a lot of misleading things that are on this graph. This is very recent. This is this past summer, spring, summer. And so misleading graphs still happen today. And the goal of statistics is to make you see and be aware of these things. This one, for people under 60, coronavirus is less dangerous than the seasonal flu, was tweeted out. And you see this graph and you think, okay, I mean, look at the COVID-19 in South Korea and the flu on the left. And you see this visually drastic change on it. What can be so misleading about that is, well, look at your x-axis. 0 to 4, 5 to 17, 18 to 49, 50, 64, 65 and older for the flu. It doesn't match the axes on the right side for it. Under 30, 30 to 39, 40 to 49 they're not really the same width on it. When it comes to the boxes on them, the intervals, the bins, better word, the bins for them on it. So this type of stuff still happens today. Now, some other misleading things in the last two is these two graphs, graph A, graph B, show the exact same data. And I mean, look at it visually. They show the same information, but one looks more drastic than the other. And the reason why is because of where the y-axis is starting. On the left-hand side, it's starting at 0, and the scale is going up by 4s. But on the right-hand side, I have a little break here. And that break makes it start at 14. It goes up to 24. They're the same exact numbers, but the right-hand side, I mean, it looks so much more. It looks over 2, maybe 3 times as much snow in 2002 as we had in 2001 visually based off of area. So we need to be careful with how we label the y-axis. And the same goes here. The y-axis here, it's the same data in both interest rates, but one has the y-axis labeled very by small intervals. Here it's starting at 0, unlike the other, and it's going up. Well, we see that the interest rates aren't that bad on this right-hand side. They're pretty similar to each other. But on the left-hand side, it looks like they have increased drastically. So graphs can be misleading on it. That's the 1.1a content for this lesson. Mr. McNichols will be making the video for 1.1b.